Hello good people, I'm going to continue talking about covalent compounds. I'm going to use 4 diatomic molecules to illustrate the different ways that electrons can be shared. Recall that diatomic simply means a molecule that is made up of 2 atoms. In order to demonstrate what is happening, I have drawn Lewis dot structures. Not only are they great to tell me how many valence electrons there are, but I can also use them to determine how many bonds a particular atom wants to form. The key is in the unpaired valence electrons, or the single valence electrons. So hydrogen here on the left has 1 unpaired electron. This means it wants to form 1 covalent bond. Oxygen has 2 unpaired electrons. Therefore, it wants to form 2 bonds. Nitrogen has 3 unpaired electrons and will want to form 3 bonds. Chlorine has a single unpaired electron and will desire to form a single covalent bond. Recall that each covalent bond represents a sharing of a pair of electrons, or a sharing of 2 electrons. Okay, so let's start with the hydrogens on the left. Each hydrogen has a single unpaired electron. Therefore, each hydrogen wants to form a single covalent bond. But a single covalent bond requires 2 electrons. So by sharing their electrons, like so, we will end up with a covalent bond. And I can now write this as hydrogen dash hydrogen. The dash, or the line, represents 2 electrons that are shared and that are responsible for a formation of a single covalent bond. In case of oxygen, each wants to form 2 covalent bonds. And so these 2 electrons will be shared and these 2 electrons will be shared as well. In this case, 2 pairs of electrons are shared between the atoms. This means that we will end up with 2 covalent bonds between the oxygens, or we simply call that a double covalent bond. And I would indicate that by having the oxygen, and then 2 lines, and then the second oxygen. What about the nitrogens? Each nitrogen has 3 single electrons, therefore it will want to form 3 covalent bonds. And again, we will have sharing of electrons. So these 2 will be shared to form a covalent bond, then these 2 will be shared to form a second covalent bond, and then I will also share, or more precisely the nitrogens, will share these 2 electrons to form the third covalent bond. And now we end up with a triple bond between the nitrogens, and we indicate that by using 3 lines. Again, each line represents a sharing of 2 electrons. What about the chlorines? Well, each chlorine has only 1 unpaired electron. Therefore, each chlorine wants to form a single bond. Again, we will end up with sharing of electrons. So these 2 electrons will be shared, and we will end up with a chlorine line indicating a covalent bond, and then another chlorine. What would be the formulas for each of these compounds? Starting on the left, we have 2 hydrogens. We indicate that by writing H and then a 2 in a subscript. This is now known as molecular hydrogen, a single molecule of hydrogen. To the right, we have 2 oxygens, so it will be O and then a 2 in a subscript. This is now a molecular oxygen, a single molecule of oxygen. Then we have 2 nitrogens, so it's going to be N2 with the 2 in the subscript. Again, this is now molecular nitrogen, a single molecule of nitrogen. Moving to the right again, we have 2 chlorines, so it's Cl and then 2 in subscript. And now we have molecular chlorine, a single molecule of chlorine. Keep in mind that each line between 2 atoms represents a sharing of 2 electrons. So with molecular hydrogen, I could have written it as H, H, and then two dots in between, indicating the two valence electrons that are being shared. For molecular oxygen, I would have two oxygens, and now I need to have two pairs of shared electrons. So here's the first pair, and here's the second pair. If I insisted, I could also add the lone pairs of electrons. So here they are as well. In case of molecular nitrogen, I have two nitrogens, but they have three lines between them, meaning that they are sharing three pairs of electrons. So here's the first one, the second one, and the third one. And again, if I insisted, I could also add the lone pairs of electrons. And finally, with molecular chlorine, I have two chlorine atoms. They are sharing a single pair of electrons between them, so here it is. And now I could also add all of the lone pairs. And here they are as well, lots of little dots. In summary, the unpaired electrons in Lewis dot structures can be used to determine how many covalent bonds a particular atom wants to form. Each covalent bond represents a sharing of a pair of electrons. Depending on the atoms, we can have single, double, or triple bonds. We will further explore this in future videos. Right now, I can sense some of you falling into a coma, so let me just say that is all for now, and I will see you on the flip side.